A block of mass 4 kilograms is made to move in a straight line on a rough horizontal surface by a horizontal force of 50 newtons, as shown in the diagram. Assume that there is no air resistance acting on the block. Draw a diagram to show all the forces acting on the block. Find the magnitude of the normal reaction force acting on the block. The acceleration of the block is 3 meters per second. Find the magnitude of the friction force acting on the block. Find the coefficient of friction between the block and the surface. Explain how and why your answer to part D would change if you assumed that air resistance did act on the block. Okay, so here we have the question summary form then. First of all, we need to show the forces. Well, first of all, there's the weight, mg, so that's 4g, isn't it, because it's a 4 kilogram mass. It has a normal reaction, which we'll label as R, and then we've got our frictional force. Because it's being pulled along, we know that this is going to be mu R, where mu is the coefficient of friction, because it's a rough surface. So there's the forces then. Find the normal reaction. So part B now, the normal reaction. So let's resolve forces vertically then. R minus 4g are the vertical forces here and here. There's no acceleration, so it's equal to 0. So that tells us then that R is equal to 4g. So R is 4g. That's the normal reaction. If A equals 3, the acceleration, find the frictional force. So let's do part C then. F equals ma. Horizontally gives, so let's apply F equals ma horizontally then. 50 minus the mu R, which is the frictional force, is equal to the mass, which is 4, times acceleration, which is 3. So let's just check that then. Horizontally, this force going this way, 50 minus mu R, which is the force in the reverse direction. There's no other horizontal components of force, so that would equal the mass times the acceleration. Mass is 4, acceleration is 3. So that tells us then, move the mu R over here and read it from right to left, is equal to 50, leave as is. This is 12, move it over to be with the 50 minus 12. So mu R equals 38 newtons. There's our resistant force due to friction. Let's see. Now find mu. So D. So mu R, R is 4g, so mu times 4g is equal to mu R, put that in there, is equal to 38. So it tells us that mu is equal to 38. Move the 4g from times to divide. 38 over 4g, so 38 divided by bracket 4 times 9.8, close bracket, 0.969 to 3 significant figures. And that was to 3 significant figures. So that's the coefficient of friction, mu. If air resistance did act, how would D change? Well, if there was air resistance here in the picture, whereas it's going to still have acceleration 3, nothing else has changed. If there was air resistance here as well, then of course this force would be a component of the total resistant forces. So mu would be a smaller value. Mu would be smaller.